normality assumption when we are comparing two groups is not often satisfied. When the normality assumption does not hold true, then we perform non-parametric tests instead of using the usual parametric test, like two independent groups t-test. In this case, when the normality assumption does not hold true, we need to find other alternative tests. One of the other alternative is the median test, where we can make the comparison between two medians. So a drawback of using it is that it does not make full use of all the information present in the two samples when the variable of interest is measured at least on ordinal scale. So if for testing the desired hypothesis, there is available process that make us of more of the information inherent in the data. Such a non-parametric procedure that can often be used instead of the median test is the Mann-Whitney test. This test is also known as Mann-Whitney-Wilcoxon test. So since it is based on the ranks of the observations, it utilizes more information than its alternative. So to carry out Mann-Whitney-Wilcoxon test, we have certain assumptions. The very first assumption states that the two samples of sizes n and m, they respectively available for analysis, have been independently and randomly drawn from their respective populations. The second important assumption is that the measurement scale is at least ordinal. And when we say it's at least ordinal, we mean to say it can be ratio, it can be interval. But certainly we don't do it if our measurement scale is nominal. Third assumption states that the variable of interest is continuous. And fourthly, if the population differs at all, they differ only with respect to their medians. This often happens when the normality assumption doesn't hold true. The testing process starts with stating of the hypothesis. Since here we are assuming that normality assumption does not hold true, hence we cannot use mean to make the comparisons. And for this, we will use medians. Our hypothesis can take different forms, where our null hypothesis will certainly always use the usual rules for making the null hypothesis. Here, M1 denotes the median from the first group, and M2 denotes the median from the second group. Our first null hypothesis states that median in the first group equals median in the second group, against the alternative hypothesis that median in the first group is not equals to the median in the second group. One can also make another hypothesis, where null hypothesis is that median in the first group is less than equals to the median in the second group, against the alternative hypothesis that median in the first group is greater than median in the second group. And likewise, the third form of hypothesis, where median in the group 1 is greater than equals to median in the group 2, against the alternative hypothesis that median in the group 1 is less than the median in the second group. Here we are stating the second step, where we are stating the level of significance, which is denoted by alpha. A usual alpha is 0.05. This value can be changed. The third important step is to state the test statistics. Though there's a specific process to make these calculations, but the test statistics denoted by T for the Mann-Whitney test is equals to S minus N into N plus 1 by 2. The fourth step, as usual, is the calculations. Fifth step talks about the decision rule. If we are using decision rule as p-value, then our decision rule states that we reject the null hypothesis if p-value is less than equals to alpha. But if we are going to use the other approach, that's critical region, then we reject H0, that is a two-tailed, that median in the first group is equals to the median in the second group. If the computed T is less than W alpha, where this W alpha is a critical value of T obtained by entering the table, in the appendix table L, which I'll be sharing in the next slides. And we will compare it with N. And the number of X observations, M, the number of Y observations, and alpha, the chosen value of significance. If we use the Mann-Whitney procedure to test the hypothesis median in the first group X that is less than equals to median in the second group, that is Y, against the alternative hypothesis that median in the first group is greater than median in the second group, is sufficiently large values of T will cause rejection so that the decision rule is stated above. Then we reject the null hypothesis that median in the first group is less than equals to median in the second group. And if computed T is greater than W1 minus alpha, where 1 minus alpha is equals to NM minus W alpha. So for the two-sided test situation with the stated null and alternative hypothesis, computed value of T that are either sufficiently large or sufficiently small will cause rejection of null hypothesis. And thirdly, we reject H0 if Mx is equals to My. If the computed value of T is either less than W alpha by 2 or greater than W1 minus alpha by 2, where W alpha by 2 is a critical value of T for N, M, and alpha by 2 that is given in the appendix table shown in the later slides. Using this information, we will make our decision, and finally we reach the conclusion. Whenever we state the conclusion, we are supposed to write statistical conclusion and then application conclusion. Statistical conclusion usually states whether we want to reject the null hypothesis or not. But application conclusion is stated keeping the whole scenario in mind, that the problem under study and what our statistical conclusion states. Here are some additional comments about the shape and the critical region. Since we are aware that the distribution is not normal and it's very likely it may not be symmetric, that is the situation when we will use non-parametric tests. Let's assume this one shape, and it not necessarily has to be like this exactly. It can be of any other shape, but non-symmetric. If our null hypothesis is one-tailed against with alternative hypothesis that median in the group 1 is less than median in the group 2, we will look at the lower tail on this curve, and the shaded region will be our critical region. Against the alternative hypothesis, when median in the group 1 is greater than median in the group 2, we will look at W1 minus alpha, where shaded region will be treated as the critical region. But if it's a two-tailed test, it will be stated on the both sides of the curve. So let's take an example where a researcher designed an experiment to assess the effects of prolonged inhalation of cadmium oxide. 15 laboratory animals served as experimental subjects, while 10 similar animals served as controls. And the variable of interest was hemoglobin level. Following the experiment, we wish to know if we can conclude that prolonged inhalation of cadmium oxide reduces hemoglobin level. So here we have the two groups, exposed animals versus unexposed animal. We can clearly see that these two groups are independent. While we test the normality, if the distributions are not normal, then we can clearly come to perform the Mann-Whitney test to make comparison of the medians between two independent groups. So we have the hemoglobin determinations in grams for 25 laboratory animals. So, assuming that the assumption for the Mann-Whitney test are met, our null hypothesis states that the median in the group 1 is greater than equals to median in the group 2, against the alternative hypothesis that median in the group 1 is less than median in the group 2, where group 1 is exposed animal and group 2 is unexposed animal, represented by X and Y respectively. So where Mx is a median of the population of animals exposed to cadmium oxide, and My is a median for the people, or for the population of animals not exposed to the substance. So suppose we let alpha is equals to 0.05. The test statistics, to compute the test statistics, we combine the two samples and rank all the observations. Since we are assuming that our data will be at least ordinal, and it's a non-parametric test here, so we will be using a lot of ranking around the values. So we combine the two samples and rank all the observations from smallest to larger, while keeping track of the sample to which each observation belongs, keeping in view that the tied observations are assigned a rank equal to the mean of the rank position for which they are tied for. So using the data, we have this pooled data where we have X values and Y values, and we rank them. So larger value is 13.7. So here we pool these two samples. The smallest value is 13.7 and the largest value is 17.5. And ranking the observations in ascending order, the rank 1 goes to 13.7, which belongs to the first group. Rank 2 goes to 13.8, which belongs to the second group. And here we have two observations, 14.1, 14.1. Hence, these are the tied observations. So we taken the average of these ranks. So this value was should supposed to be ranked by 4th, and this was supposed to be ranked 5. So we have taken the average of 4 plus 5 by 2. The average rank is 4.5. Hence, these two values are given an average rank. So these observations are called tied observations, and these ranks are for the tied observations are the average of their possible ranks. So the next rank is 6, that is 14.2. And likewise, we keep giving ranks. So after 14.4, the next value is 15.0, which is for the second group. Hence, our next rank will go to the second group. So it's very important that we keep track that which observations belong to which group. So we have the ranks for the group 1 and we have the ranks for the group 2. And we will calculate S out of it. And here the S is 145, and using this S value 145 and N 15. So we got T is equals to 25. And our statistical decision can be taken from the table L, that is appendix, and it's given right here. So if we look at the table here, with N is equals to 15, M is equals to 10, and alpha is equals to 0.05, we can find the critical value of WA to be 45. It's right here. So since 25 is less than 45, hence we may reject the null hypothesis. And we can conclude that median in the group 1 is smaller than the median in the group 2. This leads to the conclusion that prolonged inhalation of cadmium oxide does reduce the hemoglobin levels. But if we are using the p-value approach to make the decision, so we calculated the p-value, and using this information, we can make the decision using our decision rule that if p-value is less than or equals to alpha, we reject the null hypothesis, which we can see when we perform the same test using SPSS.